Okay, Chelsea, are we ready to go?
Yeah, ready to go.
Okay, all right, I'll make a start then. Okay, thank you everybody for joining today. So what I want to talk today about is, how the university can help companies going forward. Obviously, in terms of universities, everybody's aware we teach. We teach graduates, masters, PhDs. And we also do research, but for many years now, there's been a third agenda, and this agenda is very much about how we engage with companies to drive economic development. And if we look back over history, many countries for several hundred years now have realised the economic return from investing in research. And this was initially countries very much like the UK, but this driving advances in warfare, medicine, and later advances in transport, and then really now every other aspect of society. So what I want to talk about today is really about how we drive those research outputs, but then how we create the impact from those, so how we get those research outputs out there, and also touching a bit on how we ensure that companies have the necessary skills for growth as they go forward and grow. In terms of creating an economic return from research, sometimes this is from spin-out companies that universities will set up themselves, but more commonly this is how we engage with companies. So either enabling them to commercialize the research that we've started and take that forward to new products or services, or by supporting company-driven R&D with access to specialist facilities and expertise. So in terms of agenda, I'll touch on support for R&D, and then how you can access new skills for company growth, and then finish a bit with a new area, which is really flexible courses to build new skills within existing employees. I've pinched many other slides from other people today, so it's not going to be a well scripted presentation. It'll be more sort of a rambling talk through these issues. But what I want to start off with is the Coast Lab we have at the university. So this is our coastal, ocean and sediment transport laboratory. And if you look at the two sort of photographs on the side there, on the right hand side, this is very much a unique facility. So it's a large basin. It's about 30 meters long, about 11 meters wide, about 3 meters deep. And at the top right photo there, you'll see at the end there's a load of paddles, and these paddles can be used to generate waves. Now these can be uniform waves or they can be completely random waves. And in addition to generating waves, we can also generate current within the facility. And now we're installing some new capability that can also generate wind. So the basin can be used to generate unidirectional and directional wave fields, regular waves, wave spectra and currents. And this is a very important facility because obviously in terms of the ocean, it's a very inhospitable environment, and if you're developing any piece of equipment to go in the ocean, you need to test this, and this is where this facility comes in. At the other end of the laboratory there's a much shallower basin as well, and in that shallower basin we can model sort of coastlines, and we can see how wave impacts will impact that coastline over time. This is also very important as sea level rises. Sea level rising quite rapidly at the moment, and one of the interesting experiments we've done in that lab recently was to look at the Wolf Rock Lighthouse and how rising sea level will impact on that structure as we go forward. So it's a facility, where we do a lot of physical model testing. We do sometimes put full-scale devices in there, but usually it's scale models. So these may be 1/10 scale or whatever scale, but this will then give us an idea of how those devices put in that lab will react in the actual environment. So it's a sector leading facility. It's pretty much a unique facility in the UK, and it's certainly one of the leading facilities globally. And this is very much used for the testing of wave, tidal, onshore wind, offshore renewable energy devices. And as well as testing the scale models in there, we also use CFD, so computational fluid dynamics, and very much look at the sort of numerical side of how those models are responding in that environment. And as I said earlier, this research is also applied to robotics. So we put several robotic platforms in there, particularly robotic surface vehicles. You know, as they're fundamentally being designed, these things have to last within that harsh, hostile ocean environment for many months at a time. So we've put those in there. We've subjected those to wave patterns of all sorts, just to see how the hull forms of those surface vehicles will respond as well. In terms of floating wind, so floating wind is something we can very much test in there, because we do have the currents, waves, and now wind. And you know, floating wind does already exist. There is the high wind development up in Scotland, but floating wind hasn't yet been optimized. And what the Coast Lab allows people to do is, you know, develop a structure that is genuinely strong enough without being over-engineered. And obviously, if you start to get into over-engineering, that increases the cost of the structure. So it's about allowing companies to develop an appropriate structure for that hostile environment. And we've very much used this facility for working with companies. These slides are a little bit out of date, but we've supported probably over 45 businesses now on over 53 commercial projects, and this since the Coast Lab opened in 2012. And you know, we've had collaborations with DNVGL, Arup, Carnegie, AMOG, Core Power, ARC Marine, etc., etc. And the key thing, I mean, this is a key thing for the university more generally. You know, we work with firms both large and small, local, regionally, nationally, and right across the world. You know, we work with companies of all different sizes. And a couple of case studies here. So Marine Power Systems, they're developing a flexible ocean energy technology which can be configured to deliver wave power, floating wind power, combined energy generation at grid scale. And they've used the Coast Lab extensively for the development of 3 devices: wave sub, wind sub, and also dual sub. And in addition to doing the actual testing of the models in the lab, we use the lab's motion capture technology as well. And this allowed detailed analysis of the behavior of those devices. And we got some pretty impressive HD cameras, both above the waterline and also below the waterline. And this, you know, really allowing the company to have a look at how those devices are responding to that ocean environment, or that simulated ocean environment. And you know, just a quote there from the company at the bottom, we've been able to use this video material to present and explain, you know, their devices to investors and at conferences going forward. So that's sort of wave energy devices. And another company that we've worked with quite extensively over the last few years and are doing incredibly well at the moment is ARC Marine. And ARC Marine started developing reef cubes. So obviously, if you've got to protect a coastline, you can drop blocks of concrete in there. That's a given. The difference with the ARC product was that it had lots of nooks and crannies, which would actually encourage species to actually take hold. So as well as protecting the coastline, you're also sort of enhancing the species that actually take root there. So that was a very beneficial product. And the secondary product they developed, or the secondary application they developed, was using multiple amounts of those blocks there. And you'll see on that middle photograph on the right-hand side, so multiple blocks contained within a bag. And this very much to protect fixed wind masts. So fixed wind fixed to the seabed. The wave action causes erosion or scour around the mast of that turbine, and over time that can reduce the life efficiency of that fixed wind platform. So dropping bags of these blocks around that mast at the bottom greatly extends the life. And the bottom photo on the right hand side is some of the numerical analysis that was done in the lab. So you'll see there a mast of a fixed wind turbine with these blocks situated around the bottom, and over time we could predict just how much those blocks would protect erosion from scour. So that's just one example. That's just the Coast Lab. The Coast Lab, we've worked with many companies, as I've said, and there's a lot of supporting funds available to make sure that universities now can support companies going forward. So those examples I've mentioned have used Horizon 2020 funding, so European funding. They've also used UK funding, so this might be funding from research councils or under the Industrial Strategy Challenge Fund, but we've applied many different sources of funding to support the work we've done with companies. And now moving on to another example, and I pinched a colleague of mine, Steve Rice's slides here, and Steve did a presentation within this series a couple of weeks ago, so I'm not going to go over these extensively, but this is just another example of a way we support companies. And this is using European regional development funding under the Marine Business Technology Centre. So this is a project led by Plymouth City Council, which is why we're all here today. This series is part of the MBTC, but it's very much support for local companies around high-tech marine development. There's a lot of activity going on at Oceansgate, the Oceansgate Enterprise Zone, but MBTC itself was 4.5 million of ERDF funding, and this is a programme running out to 2021. And a key way that we're supporting this programme and how we're supporting local companies working in this space is via the use of this platform. So this is an unmanned surface vehicle. We call it Cetus. It was provided by a company called L3 Harris. And this is quite an expensive bit of kit to own, and it's quite an expensive bit of kit to operate. And if you're a company developing products or services to work in the hostile environment that is the ocean, it's very difficult to actually get access to platforms to test those devices, whether it's sensors or whether it's survey methods or whatever. And this is where we come in, because what we can do via the MBTC project is give companies access to this facility. Provided you meet the criteria in terms of geography and size, this isn't going to cost you anything, and you can stick your device on this platform and we can see how it performs. This often tested within Smart Sound Plymouth, so this is another key facility. This is 1,000 kilometres squares of deconflicted water space where we can attach devices to that unmanned surface vehicle and literally go and test them and see how they perform. So in terms of what we can offer there, so we own the platform, we've got the knowledge and experience to operate that platform. That's not an easy thing to do. You need quite a lot of expertise to actually keep that piece of kit in the water and operating properly. And we've got experienced skippers and crew to support that. All the testing is done compliant with UK Marine Autonomous Systems Codes of Conducts, and we make sure we got all the necessary permissions in place so that we can go and operate that vehicle. So this sort of activity would be beyond the means of most small companies, and the fact we've got that vessel and we're then offering that to those companies is a real advantage for many who've engaged with it. This is the marine station at the university. This is where we house Cetus, but also that facility there provides water access from pontoons, lifts and slips, and ways of storing equipment. So again, these are facilities that normally would be beyond the reach of small companies, and this program MBTC will therefore provide the funding to allow those companies to access these facilities. And my colleague Steve went over these in more detail a few weeks ago, but these are this is some of the feedback from the companies we've been working with, and there's a growing number of companies we've been working with Cetus. So CREG's highlighting how engaging with that platform has allowed the company to aggregate the component learning and create a standardized training and safety system. Reef Cube's USV platforms offer the company significant commercial advantage as it means to perform ongoing new site identification. Silicon sensing, these actually providing sensors, and as they commented, access to offshore assets to perform tests on both component sensors and prototypes will provide valuable data to validate and optimize those sensors. So a lot of companies we're engaging with, all very pleased to be able to access that platform. So that's another example of how we, the research base, are working with companies to drive forward R&D to create new products and services. Now, a third example, and this one I've been very, very closely engaged with over the last 2 years, and this sort of takes a sort of different tack, really. So this is around maritime cyber security, and maritime cyber and shipping is a massive issue. Shipping is a pretty sort of unique problem space for cybersecurity. Shipping platforms typically operate over 25, 30 years. They often have sort of very old legacy systems with a lot of sort of autonomous additions to that legacy system. And this complex system of systems means that it's very sort of vulnerable to cyber security. And there's a growing number of instances pretty much on a weekly basis now, highlighting how shipping systems have been infected with malware, and malware not necessarily designed for that shipping system in most cases, although increasingly now we are seeing that there are specific targeted attacks on that shipping system. And it's not only malware, we've also got the issue of state-sponsored GPS spoofing, this Iran and Russia particularly, but that shipping system is experiencing a lot of issues. So when I joined Plymouth just over 2 years ago, I started working with a range of stakeholders, and we had 18 partners join with us, and these were partners including ship's bridge equipment manufacturers, shipping operators, insurers, class societies. And we collectively put a proposition into something called Research England, and Research England funds new laboratory facilities for the UK. And this was around something we're calling the Cyber Ship Lab, and SHIP being an acronym for Software, Hardware, Information and Protection. And you'll see at the bottom there some of the logos of the companies that are working with us on this. And essentially, in a nutshell, what this is going to be, it's going to be an actual ship's bridge. So we're going to build a ship's bridge with all the necessary equipment you'd normally find on that ship's bridge, but this is going to be in a lab environment at the university. And once we got that ship's bridge, and it's going to have a range of equipment that can be representative of most of the ship's bridge layouts that are out there, because ships do vary tremendously in size. You might get, bulk carriers, but you also get cruise liners, and you also get fishing boats, you get speedboats, etc., etc. So this laboratory is going to be able to replicate the vast majority of ship's bridge layouts that are out there. And essentially what we're going to do is we're going to bombard this ship's bridge setup with known malware, custom crafted malware that we can create in the university's cyber ranges, and also the impacts of GPS spoofing. And then what we're going to do is we're going to see how the individual components of that ship bridge system perform, and which components start to fail, and what the impact of the individual component failure is going to be on the wider ship's bridge system. And when we start to understand the genuine impacts of maritime cyber issues, then we can replay those in our ship's bridge simulator so that we can get into advanced training for seafarers. And what is this going to look like? Well, it's going to have two halves essentially. The lab was supposed to be finished in June this year, but of course COVID hit, so we are making good progress, and the lab is coming together at a rate of knots now, and we expect to now have this completed by sort of February, March next year. But it'll have a room which will be the sort of laboratory analysis section where we can get into what the impact of the ship's bridge is going to be. And at the back end will be the vault where we contain all the necessary ship's bridge equipment. That can be ECTIS, radar, voyage data recorders, etc. And then what we will do, depending on the ship in question, whether it's a Queen Elizabeth aircraft carrier or whether it's a container vessel or it's a cruise liner, we will select the necessary ship's bridge equipment that will be representative of that vessel. And then, like I say, we will then subject that to known malware, custom crafted malware, just to see how that responds. And then as we go forward, this will create resilience for the sector. It will allow ship's bridge equipment manufacturers to make their equipment more resilient. It'll allow us to work with class societies and insurers to make sure that new policy and regulation is in place to make sure that ships are safer as we go forward. So 3 examples there of different facilities: the Coast Lab, the USB we now have under MBTC, and the Cyber Ship Lab. So 3 examples, different research assets that we're very much applying to work with companies to drive improvements in key areas, whether that's new offshore renewable energy devices, whether it's new sensors for the marine environment, or whether it's cyber resilience for shipping. The next area I wanted to touch on in this presentation this morning was how companies can access new skills for their business. And this can be done in a whole variety of ways. So placements are a very good way. Yes, you can take on our graduates once they graduated, whether it's at graduate level or master's level, you can employ those as a company. But you can also take on placements. But what I wanted to touch on today is something that I don't think is used enough. It's a fantastic scheme called Knowledge Transfer Partnerships, or KTP for short. And KTP has been running for over 40 years now. It's one of those grant mechanisms that has survived the test of time because it really does work very well. Now, it can be applied to a whole variety of situations, but the case study I want to use this morning is a case study with Red Paddle. So firstly, what is KTP? Well, a knowledge transfer partnership enables a company to bring in new skills and access the latest academic thinking. And this has to be focused on a strategic project for the company. So a company that delivers a specific strategic innovation through this knowledge-based partnership. So the academic partner will provide the academic input. We actually nominate a supervisor, so one of our senior academics in the university. And we then recruit a graduate. That little sound I've just heard in the background probably indicates my broadband is fading in and out, so sorry about that. We then recruit a graduate who is known as the KTP associate. Now, this graduate works in the company pretty much full time, and this is the main source of expertise that will then drive those new developments in the company, mentored by the academic supervisor. And KTP is a very flexible scheme. It can be for projects lasting between 1 and 3 years, depending on what the project need is. And in the case of Red Paddle, so Red Paddle Company were one of the first companies to challenge the accepted practice of rigid paddle boards. And they introduced an inflatable alternative all the way back in 2008. And what the university did was identified areas of disruptive innovation that would then lead to advanced next generation of inflatable paddleboard products. And by working with Red Paddle, the developments we created with them really sort of pushed their products in the marketplace and created a compelling customer proposition by using enhanced materials, manufacturing and design techniques. And if we look at some of the outputs from KTP with Red Paddle, what it delivered was a next generation pump that was developed and optimized using advanced computational fluid dynamic modeling techniques. and also accessing the rapid prototyping and laboratory testing facilities of the university. Again, these facilities typically beyond the cost, beyond the sort of accessibility of small companies, but by collaborating with the university, this company was then able to access these facilities. It allowed new design processes, design tools to be embedded within that company, and enhanced paddle and fin box design that applied the new design process to accelerate the product development, and also employed finite element analysis. So this is a way of sort of testing the outputs of whatever you're developing. So KTPs, like I say, placements are another way, but KTPs are a very good program to allow companies to access new skills and new thinking that can really leverage leading thinking within universities, but also can allow the companies to access their facilities. Now, lastly, I want to touch on today is flexible learning. And if there has been any advantages coming out of this dreaded COVID situation we've all been impacted by this year, there's been a realization that, you know, a lot of talk programs can be done flexibly. You know, we are now having to adopt a process of blended learning for our students. So yes, there are some class-based activity, but a lot of the tuition is now being done online. Now, degree apprenticeships or higher degree apprenticeships were about before COVID happened, but I think, you know, the fact we've pushed a lot of material online now is going to enhance our offering around degree apprenticeships and higher degree apprenticeships. So just explaining a bit about what they are. So most companies pay to HMRC something called the apprenticeship levy. So large companies have to pay a tax into HMRC, and what it enables them to do is access programs via degree apprenticeships or higher degree apprenticeships to draw that money back to actually train their existing staffing base. Now, small companies can engage in this as well. It's not just large companies who pay that apprenticeship levy. And a lot of the smaller companies engage with the monies paid in by large companies in the supply chain. But even if that's not the situation, small companies can still engage, and most of the costs of a degree apprenticeship or higher degree apprenticeship will be met by grant. So in terms of recruitment, it lowers recruitment costs, and an apprentice is a productive and effective way for an organisation to grow. Like I say, the funding bit is accessed. Most of the funds, if not nearly all the funds for degree apprenticeships, are covered. It's a very flexible way of learning. Coming back to what I was saying about COVID, you know, what we're not asking companies to do is send existing employees to classroom environments for weeks on end. This is a very flexible way of learning. It can be, you know, half a day a week or a few hours a week. Sometimes there are modules where they need to come into the university, but generally this can be conducted at work or at home. And it allows companies to develop talent, you know, to increase the skills they have in their business. And then obviously as they apply those to whatever situation they work in, that's going to increase their productivity. If you're an apprentice, so someone who enrolls on one of these programs, it allows you to study towards a bachelor's or master's degree without that burden of student debt. You know, students do come through university, it does cost them money. Obviously, we ask them for a contribution to their tuition fees, and they then have to get, you know, premises to live in, etc. So studying for a degree is a significant investment, but a degree apprenticeship or higher degree apprenticeship, you know, allows existing employees to go through that bachelor's or master's degree route without that student debt. Obviously, you retain your existing job, so you're sort of earning while you're learning. It's funded, as we've said, and it provides an alternative route to traditional university. You know, if you've been working in a company for 10, 15, 20 years, you know, it still allows you to get that first degree or that master's degree without going through the formal university route. You do end up with your degree, but you also end up with your certificate of training, whether that's the degree apprenticeship or higher degree apprenticeship. So it's a very attractive package all round, a very attractive package for the employer and a very attractive package for the apprenticeship who would be enrolled on that. And staying with the theme of NBTC today, I just want to focus a little bit on our new MSc in Autonomous Systems Technology. So this is a traditional MSc program that is being taught at the university, but we have also made sure that this is available as a higher degree apprenticeship. So it's a unique program in the UK, providing a strong skill set in marine and robotic autonomy. And it's really aimed at those who want to increase their knowledge of different types of artificial intelligence based techniques. These that can be used to increase production, improve performance and reduce costs. So yes, it can be applied to CETUS and marine autonomy there, but this is also applicable to autonomous systems more generally. And as I said, staying with the theme of higher degree apprenticeships, learners will gain an MSc in autonomous systems, and this fulfills both CEng and UK spec standards. But by the end of the programme, they also will achieve their postgraduate engineer degree apprenticeship. And as I said earlier, organisations that pay the apprenticeship levy, so this will be paid for via your existing levy account. And for smaller companies who don't pay that apprenticeship levy, they can receive up to 95% of costs via grant. So that's pretty much the end of what I want to say today. And I've covered why universities work with companies, and hopefully I've sort of inspired some of you who maybe haven't worked with the university before to come and talk to us. Every company's needs are completely unique. So, myself, there's a whole team of people in my office. If you want to speak to us about how we can help you, we always apply grant funding wherever possible. We've got a good knowledge of all the different regional, national and international funding opportunities that are available. So please do make contact, and we can advise you on how we can help and what funding we can draw down to help you. If it's something we as a University of Plymouth can't do, then we have an extensive network of other universities and other research universities across the UK. So, if it's something we can't do, we can also put you in touch with someone who can. But thank you very much for listening, and my contact details are there, and please do get in touch with myself or Chelsea for any follow-up inquiries, but happy to take any questions now.
Thanks, Kevin. If anyone could just type any questions in the Q&A chat bar to the side, I'll give you a couple of minutes to do that.
I think I'm off the hook, Chelsea. I must have either done a very good comprehensive presentation or missed the bit.
We'll go with that, Kevin.
Okay, we'll go with the form. Yeah.
Okay, everyone, thanks for attending today. And if you do have any follow-up questions for Kevin, all his contact details are there. We will also be posting this webinar live on the Oceansgate website and also on social media if you do want to rewatch any of it. Thank you, Kevin, and thanks everyone for attending.
Thank you very much, Chelsea, and yeah, thanks everyone for listening, and please do reach out to us afterwards and we'll see how we can help. Thank you very much.
Thanks, bye.
Bye-bye.